Okay. Now, this is the last chapter.
Yay.
Yay! It's the final countdown!
Final unit.
Okay, final unit at least. Okay, so, right here, complex numbers. You guys did this in Algebra 3-4. I guarantee you did it. You guys probably did it in Algebra 1, if you paid attention. Okay? There's a lot of times in which that you've done this. Now, a complex number, okay, refers to a couple things. I
Oh
is
my
the
god, I
imagine.
hate this.
I will make it fun. Okay?
I hate this imaginary number.
I hate
Okay.
this.
So,
I'm mad.
okay, mad. All right. So, now there's a lot of rules that go along with this. Okay, a couple of them are pretty easy. I squared
It's negative
is -1, where I is just
square root.
square root of -1. Now, what happens when I square a square root?
That's-
The root goes away, right?
Yeah.
Okay, that's where I get the -1 from. All right, so it's pretty simple, right? And be a real number is then any number of the form a plus bi. Where's the I at?
Yeah.
At the end, okay? So is a complex number that the complex number a plus bi is the, okay, a is the real part, b is imaginary part. A is real, b is imaginary. It's always in that form. All right, come on, you can do it. There we go. All right.
You know.
Okay. So, do you know what? Let's make it to here. Okay. So, remember way back in the day when you actually had like the number sense and actually had to like whole numbers, natural numbers, integers, rationals, irrationals, real numbers, all these are real. Then we had to talk about non-real. Non-real numbers are imaginary numbers, but these are still part of numbers. Yes? Okay. All right.
I can't see the numbers.
I know you
That's
can't
alright.
read nothing on that.
To like the lights off.
Okay, so
We have the lights on.
no. How about this right here? Can you read this one?
No.
Yes.
Try again. All right, now, isn't this, so I'm going to do this in a couple different ways. So now if we look at this, we can factor it out. Because we know that -1 is in there, isn't it? So I'm going to write that out. So it's going to be equal to the square root of -1 times the square root of 16. That's one way. I have taken the -1 out. And I'm going to deal with that. So the square root of -1, I already know that's I. But now then the square root of 16, that is a perfect square, which is going to give me what? 4. So now put them together and I get 4i. Because this right here is my I, and this piece right here gives me 4. And I multiply them together.
That's 9.
Yes, that's an I. Anyway, all right. So factor this thing. So I'm going to factor it. So it's going to be -1 times. Now, square root of 70 is not a perfect square. So I'm going to start looking at that. That's going to be, let's see. Let's do all the factors. So that's going to be 7, right? Times 10. But is 10 factored completely?
No.
No, that's 2 and 5, isn't it?
Yeah.
Okay, so those are considered prime numbers. So those are prime numbers. They cannot factor any further. So this number, 70, breaks down into 7 times 2 times 5. Is there any perfect squares in there?
No.
No perfect squares. If there's no perfect squares, then I leave it alone.
So we just leave it as 70.
So I would leave this alone. So I put them all back together. I factor it to see if there's a perfect square. Just to see if it's there. This one's not there, so the only thing I could factor out of that is what? My I, right?
Where I don't know
What? Speak to me.
why are you just throwing in a -1?
What is -1 times 7?
-7.
Right? So -1 times 70 is -70. So there is a negative inside there. So I'm using it as a -1. Okay, so just leaving it as just a negative by itself is not very helpful. But -1 we know is the I. So from here right here, so the only thing I'm going to do is take out that I. So I'm going to be left with I square root of 70. Now, you could also put the I at the back, but that's a preference issue. Okay? If I have a square root and an I together, you could put the I in front, or you could go square root of 70, but make sure there's some space that the I is not inside the radical. That's the only reason why that I would write it like this instead of like this, because if you have it like this, you have to make sure that there's a clear distinction that the I is not inside the radical, especially if you're putting it in your calculator. You want your I in front because when you do it in your calculator, you could barely see a difference if it's still inside the radical. Makes a huge difference there. All right, so let's take a look at this next one right here. So break it down again. So that's going to be 1. So my -1 square root of So I don't know why I keep doing that. It's weird. All right, times. Now 48. What times what?
12 and 4.
12 and 4. Okay, I'm going to use a 12 and 4 here for this case right now. So I'm going to show you guys why. So it's going to be a 12 times 4. So I'm going to use a 4 here. Why would I use a 4 there? It's not a prime number, but why would I use 4? It's a perfect square. That's the part I'm trying to get at. So that's a perfect square. So there's still a 12, right? Yeah. Can 12 factor further?
Yes.
Yes, it can. 6 and 2 or a 4 and 3. That's the part I wanted. I would use a 4 and a 3. Now, the 4s are not primes, but they are perfect squares. So that's what I'm trying to get at. So I wanted these to be factored. Okay, I could have just taken 48 and say, hey, that's 16 times 3. That's another way of writing it. But I'm pretty sure people don't know their multiplication times all the way out to their 16. So, yeah, you did? You knew that? He said he knew it.
Who, Manny?
Yeah.
Knew what?
All right, so
Knew what?
so right here, so let's take a look at what we have here. So now, this is going to be 2, right? This is also 2. Those two 2's is going to give me what number? 4. So I'm going to have 4 on the outside. So there's a 4.
Wait, 2, 2.
Okay, what's square root of 4?
2. Oh, 2.
Yeah, so this is going to be 2 right here, and this is also 2 right here. So 2 times 2 gives me the 4, and then this is going to give me I, and then what's left? Rad 3. Yes?
You're doing the pointing thing again?
The
Because
pointy?
you just added them? The 2 2's?
Yes, right here.
You added them?
Yeah, I didn't add it, I multiplied, because look, it's a multiplication all right here.
So you're just factoring.
Yeah, so this is for factoring.
So, like, if it was 2 and 6, it'd be like 12i. I'm just saying, like.
Yeah, so if it was a 2 and 6, it would be
you don't
12.
add
Yeah,
them.
you multiply.
Okay.
Yeah, that's why I put the little multiplication dots in for each one of these there. Okay? All right, so now that's what we're going to come up with there. So I put my constant real here. Okay, I put my I, my imaginary, and this one right here is my radical. So this whole thing, because of that I, is imaginary. This is also imaginary. That's also imaginary. Now, this one goes back to that algebra 3-4 skill. When you take the square root of both sides, what do you have to account for? You guys recall? For right here, to get x by itself, what would I do?
Square root.
Square root. So I'm going to square root both sides. So let's do that. Square root and square root, right? But when I take the square root of something, I have to account for one thing. Plus and minus. Thank you. Plus and minus. For right here, I have to account. So when I do this to both
So
sides,
it's going to be x equals to plus or minus?
yes. So now x equals plus or minus square root of -9.
But then we factor
Yeah, now we're going to factor it out. Okay? Now we're going to factor. But this piece right here. Now, we've always been dealing with the positive portion of this, okay, for a lot of these, because from Pythagorean theorem, we're only dealing with the distance, which would give me only the positive. But we still have to account for the negative right here. So we did a little bit when we were doing the x, y's, and r's, where it's a plus or minus. But for this one, you always have to account for the plus or minus. So on here, let's see. So now this is going to factor, isn't it? So this is going to give me, so it's going to break down to the square root of -1 times, okay, it stopped working. Got to wait till it starts up again. Okay, so it's going to be times square root of 9, right? So I'm going to leave it as square root of 9. Because there's my perfect square, right? Okay, so this one right here comes out to be, so x equals, so now let's deal with the plus or minus. So plus or minus 3i.
What?
Okay, what is square root of -1? This is I, right? This right here is I,
Yeah.
and this right here is 3, right? Yes, then I multiply them together, and it gives me 3i.
Alright.
Because I factored them to take them apart, so I multiplied them to put them back together. Alright, so let's take a look at this other one over here. Alright, so from here, what would I do to try and solve for my x?
Subtract 24.
Very good, so it's going to be x squared equals -24. Square root both sides, right? Square root, so it's going to be
Plus or minus.
x equals plus minus, and then the factors, okay? We're going to factor. I'm going to take out that -1 first. So square root of -1 times, now 24, there is a perfect square in there. What is it?
6 and 4.
6 times 4, right? So it's going to be square root of 4 times, now 6. Can I factor 6 anymore?
3 and 2.
3 and 2. So it's going to be square root of 3 times square root of 2. So I'm doing all this work right here. Okay, you don't have to show all this work. I'm just showing you that I don't have any more. I factored it to the smallest primes just so I could see if there is another perfect square in there.
So now how do you put it in the other?
Okay, so now I still have this left over, right? Okay, so this is going to be x equals plus or minus. Now, right here, this is going to give me a 2, right?
Yeah.
2i square root of? Yes, you put these back together. So square root of 6. So it's going to be 2i square root of 6.
Is this it? Or is
One
there
more.
still
One more.
But like, I mean, like, this is all that was, never mind.
Oh my god.
Okay, so
Oh, is that the-
into the theorem?
no, we don't have to plug it into the theorem. Here's the theorem right here. I already started it. So starting this equation right here, so you have to move everything equals 0. You guys did quadratic formula, right?
Yeah.
So in this case, I have my a is 9, my b is -6, because this got to go over here, right? -6, and the c is 5. Yeah?
What?
C is 5. A, B, C. It's almost like I put it right here. B, C, A. Okay. So, I have those values. So just plug them in. Quadratic formula. Just plug it in. It makes factoring the easiest. If you can't factor, just use this. If you know what, there's that X method, there's the AC method, there's a couple other like methods you could use, but that works all the time, every time. So, if I'm plugging it in, it's going to be, so negative b. So it's the opposite of b. So it's going to be 6 plus or minus square root of -6 squared minus 4 times 9 times
5.
5. Very good. All over 2 times 9. Okay. So time to actually do some math.
You know,
Okay, do me a favor.
Can we
Now,
just put this into our head?
not the whole thing. Not the whole thing.
Why?
Okay, see this thing right here? All that's inside the radical here, that's called your argument. That's the only piece. You're not putting the radical, you're just putting what's inside there into the calculator.
You're not putting. Okay.
Only what's inside into the calculator, that's your argument. So we get 6
Negative 186.
square root of
Oh, just kidding. I didn't.
1 what? 144?
I got some.
All over
What's 12
So then you just
So,
go through it?
hold on, I'm still waiting because people are calculating the argument still.
Yeah, negative 144.
Negative 144, yes.
Do we have to factor out the 144
Yeah.
before we can reduce the 6?
Yeah, I'm gonna do all that. Okay? Are we okay now?
Yeah.
So from here, so we only put the argument in my calculator. So, because if it's negative, your calculator's not set up for imaginary numbers right now. There's a change that you would have to make in the settings for it to be set up for imaginary. And when we start graphing these, I'm going to change your calculator to that mode. But for what we're doing right now,
We don't need it.
you don't need it. Okay, so now, given this right here, this, I know, is going to give me, so 6 plus or minus. Now, at this point, you guys should be able to tell that. So this is going to give me, so 144 is what?
12.
12, and then there's
Negative
Ah.
1.
negative 1, so that's going to be 12i. Okay? All over 18. Now, do they have a common factor? Yes, they have a common factor. Say 6.
6.
Okay, so it's going to be common factor of 6.
Yes.
Or, watch this, okay? If they're both over the same denominator, I could break that up. So this right here is going to change to be 6 over 18 plus or minus 12i over 18. Now, there's a reason why I should write it like this, okay? I can't have it over the common because it's mandatory to write my number in this form, a plus bi. It doesn't say that over 18, it's in this form. So each number is itself. So this right here is going to change the 6 over 18 because we said it's common factor of 6, so that's going to reduce, right? 1 over 3 plus or minus. Okay, this is going to give me 2 what?
2 over 3.
2i over 3. Make sure your I is either on top or notably on the side right here. Don't put it in the bottom. Okay, it never goes at the bottom, it goes on top. Okay, isn't I the square root of negative 1? Am I allowed to have a radical in the bottom? No, because I would have to rationalize that. That means that there's something different with that. So you don't put the radical in the denominator. So we're not allowed to have I in the denominator of any fraction. Make sense? All right, anyone question? Wait, hold on, watch. Okay,
Oh.
there it is. Yes?
All that justifies it. You can just write it like 1 plus or minus 21i over 3 or no?
No, because it has to be in this form. They have to be separate. So your A is 1/3. Your B is 2/3, and your imaginary, because you have your real part and you have your imaginary part. Because when we graph this later on, you're going to be graphing a real direction and an imaginary direction. All right, make sense? Questions, comments? Don't forget, like and subscribe.